Okay, now we're going to look at the three types of osmotic solutions. So we're going to draw these three beakers on the back of your note sheet. So we just need three beakers. We need to label one of them isotonic solution, hypertonic solution, and hypotonic solution. Okay, in the first beaker, we're going to make it an isotonic solution. So when you're talking about an isotonic solution, you're talking about the substances that are outside of the cell in the solution itself. Remember way back when we talked about what a solution is, it's equal parts solute and solvent. So kind of like Kool-Aid or blood. So outside of the cell is a solution. So if you're talking about it being isotonic, word iso is referring to equal. So that means the amount of dissolved solute in the solution is equal to that of the cell. And when that's the case, there is not a concentration gradient. So there isn't a place for the water to flow to. So it's not going to be moving from high to low because they're equal. And when that happens, the cell is going to remain the same size. And you can see different versions of illustration. You can find lots and lots of illustrations about the osmotic solutions. So here we can see one with the red blood cells of the water just kind of going in and out. And then we can also see the same type of situation with a plant cell. The second type of osmotic solution is called a hypertonic solution. Now we've had hyper as a prefix suffix. It's above, it's upper, it's more. So when we're talking about the solute, there's more solute in the solution than inside of the cell. So one of the main solutes that we refer to when we're talking about osmotic solutions is sodium. And we know the relationship that salt has with of sodium chloride. We know the relationship that salt has with water. It pulls water. We know that if you've ever eaten anything really salty, you've gotten thirsty. And you also know what happens to slugs when they've been introduced to salt. It's a bad situation. So if you have a situation, let's say, where there's more salt in the solution compared to the cell, then the water is going to be pulled towards the salt because there is a concentration gradient now. So the water will be pulled towards the salt, and what will happen to the cell is that the cell is going to shrink. So a couple of ways to remember this. Hypertonic solution, like a little hyperactive kid, might be really skinny. And you can see the horrible thing that happens to the cells when they've lost their water. It doesn't look so good. So we can see this vacuole is looking pretty pitiful, and we could probably see some wilting. The last type of osmotic solution is called hypotonic. Now, hypo we've also had as a prefix suffix, less, below, under. So there's less salt. There's less solute in the solution as compared to the cell. So now what that means is the water is going to be pulled towards the greatest amount of salt, and that happens to be in the cell this time. So the water, according to the concentration gradient, is going to move into the cell, and the cell is going to swell. The cell could also burst. So you see this word cytolysis. So cyto referring to cell, lyse referring to break. So the cell could break open. A way to remember this is to kind of rhyme hypo with a hippo. So a hippo, we know what they look like. They're nice and plump. And that's also the way hypotonic cells look. They also become nice and plump, and they may have a blowout. But we can see with this plant cell, what is preventing it from having a blowout is this cell wall.